Hey guys, sorry I can't be with you today. My little boy is sick, but we are going to look at Appendix B2 today. I know that we still have the second half of B1 to do, but that is all calculator, and that's something that I want to be with you to do. So if you will just skip the next page in your notes packet, the second half of B1, and let's go ahead and move to B2. B2 deals with mean, median, mode, variance, standard deviation, things that will be things you're already somewhat familiar with. So again, remember we're working in those appendices in the back of the textbook. So we're looking at page A22. Page A22. Alright, on A22 they talk to us about several different ways that we can measure the central tendency of something. When we're talking about a measure of central tendency, we usually think of that as an average. Like if you're trying to find the average of your grades, you would, add your 4 test grades and divide them by 4 to find your test average. That would be the measure of your central tendency. But there are several different ways that you can find an average like that. What we tend to think of is called the mean. When we do that arithmetic average where we add up all the grades that we have and divide by the number of grades, then that's an arithmetic average. That's the mean. And we represent that with an X with a bar over it. That's the symbol that we use for it. But there are other ways of representing central tendency or an average as well. The second one of those is a median. A median is the middle number when you put your numbers in order. So they do have to be in order, largest to smallest, smallest to largest, something like that. And it'll be the middle number when you have them in order. And then your mode is just your most frequently occurring number, the answer that you get most often. Now, each of these has a particular purpose. Although we use mean most of the time, if we were looking for something like a class average on a homework assignment, if 10 of the students in the class of 25 had not done the assignment and gotten zeros, we're not going to get an accurate measure of what the average student's knowledge was on that material, because those zeros are going to skew the data. So in that case, you might be better off to look at a median, like looking at, that would drop out the extreme high scores and the extreme low scores and give you more of a measure of the central tendency. There are other times that when I say, what's the average, I'm really looking for what's the answer that I get most often if I ask this question. For instance, if we say, how many children does the average family have? If I do a mean, I might end up with 2.3 children. Nobody has 2.3 children. What I was really looking for was what's the most frequently occurring answer to that question. And so that would be an instance where I might be looking for the mode instead. So you can see each of these measures of central tendency has its place and its purpose. There is also, there on page A22, you've got those bold print terms, mean, median, and mode, but you'll also see there bimodal. There's sometimes that you will have a set of numbers and one score will show up more often than others so that you do have a mode, but you might have 2 numbers that are just as frequently occurring. So you have a list of numbers, and in that list of, again, let's say we're talking about test scores, in that list of test scores you had 4 95s and you had 4 90s, and those were your most frequently occurring scores. So if you genuinely have 2 equal modes, we just call that bimodal. If you have 3 equal modes, we call that trimodal. More than that, we just call it multimodal. Then we can also measure the way that our data is dispersed from that center. And that's what our variance and standard deviation will do. they will give us a way to measure the dispersion of that data away from the mean. So the idea of that would be, maybe I have a class whose class average on a test is an 80, and every student in that class made between a 75 and an 85. Whereas I have a second class where their class average is an 80, but every student in that class made between a 60 and a 100. I need a way to show the difference between those two sets of information, and the mean of 80 isn't going to give it to me. I need to see how that data spreads away from that central tendency. And so that's what we mean by a way to measure the dispersion from the mean. The variance, or the standard deviation, would show me how that information spreads. Okay, so let's actually look at one of these. For the examples in the textbook, they were giving you examples where you had 20 and 30 different entries, and that's just really tedious when you've got to crunch that type of list of numbers. So instead, we're just going to use our own set of data. So we're going to use, for our example, 30, 37, 32, 39, 34, and 32. So let's start by finding the mean. Again, remember, the mean is the arithmetic average, the one we typically think of, where we would go through and we would just add those 6 scores and divide them by 6. And again, remember that we can symbolize mean with the X with the bar over it. So if I throw that into my calculator, then I would get 204. So 204 divided by 6 is going to give me 34. That would be my mean. For this portion of the test, you are going to be using a calculator that is just add, subtract, multiply, divide, square root. Just a little basic 4-function calculator. You're not using a scientific, not using a graphing. So if you want to practice with doing this type of problem on your homework with that type of a calculator to kind of get in practice, that would be a good idea. Again, the reason for that is both a scientific and a graphing calculator will find the mean for you. I need to see that you know how to find that without just hitting a button on your calculator to do it for you. Alright, then the second thing they asked me for here is the median. The median, again, is the middle number when we arrange our numbers in order from smallest to largest. So I'm going to go through and first put these numbers in order from smallest to largest, and then I can go through and find the middle number. So I could cross off the 30 and the 39 on each side, the 32 and the 37 on each side. If I cross out the 32 and the 34 that are left in the middle, I'm not going to have anything left. So if you have an odd number of entries, you'll have one number left in the middle. But if you have an even number of entries, when you get to those two numbers that are left in the middle, you are going to take the arithmetic mean of those two numbers. So literally, I'm going to add them up and divide by 2. So the mean then of those two numbers is 33, and that would be my median. All right, then mode was the most frequently occurring number. So you'll notice I had two 32s. So that's going to be my mode. That was the only number that showed up more often than the rest. So it is the only mode. It's not bimodal or trimodal or multimodal. And then our variance. Now, we actually have two different formulas for variance. And on the homework, they're going to suggest that you work out a problem by both methods. I would suggest that as well, just so you can see which one you like better. When it comes to the test or the quiz, I don't care which of the two formulas you use. So let's look at both of them. For the first variance formula, they tell you to go through and take each of your entries, subtract the mean, and square it. So you can see we're going to take an entry, subtract the mean, and then square it. And then do the same thing, go to the next one. Take the entry, subtract the mean, and square it. And keep going until we've done that with all of them, and then we'll divide by the number of entries. So what we've done down here is we took our first entry, 30, we subtracted our mean, which we already found was 34, and squared it. Then we'll take our next entry, which is 37, subtract the mean and square it. Take the next entry, which is 32, subtract the mean and square it. Take the next entry, 39, take the next entry, 34, and then take the next entry, 32. Now, instead of writing another 32 down here, what I can do is just come back here and say, hey, I've already done that once before, so I'm just going to throw a 2 out in front of this to say I have 2 of those. That's especially helpful if I have a list of numbers that maybe is like 20 numbers, but there's lots of repetition in it. I wouldn't want to have to write all 20 of them out if I could simplify that down and maybe only have to write 10 of them with, you know, numbers out in front of there are 2 of these or 3 of these or whatever. And then I'm going to divide by n. So again, I'm going to throw that into my calculator. And so I could do a little bit of simplification first before I put it in my calculator, just to make it easier to type in, particularly on like a little 4-function calculator. So I could say 30 minus 4 is going to give me negative 4. So squared would be a positive 16. And then 37 minus 34 is 3. 3 squared is 9. Then 32 minus 34 is 2. Squared is 4. So, and then we'll multiply that by 2. And then 39 minus 34 is 5. Squared is 25. And then 34 minus 34 is 0 squared. And then we're going to divide that whole thing by 6. Maybe. Possibly. Come back. There we go. Alright, divide the whole thing by 6. And we'll end up with 9.6 repeating. So that would be one way to find the variance. The second way to find the variance, well, one thing, we mentioned up here that we had 2 formulas for variance, but you'll also notice that standard deviation is just the square root of the variance. No matter which of the 2 ways you find the variance, you would just take its square root to get standard deviation. And this is the symbol that we use for standard deviation. Kind of looks like a little sideways 6. So square root of the variance is going to be the standard deviation. So since we had gotten 9.6 repeating, if I take the square root of that, then I'll have 3.109. Alright, so the second way that we can find that variance, the second formula says take your first entry and square it, then your second entry and square it, and your third entry and your fourth, all the way to your last one, divide it by n, and then subtract the mean squared. So here's what that would look like. I'm going to take that first entry, which was 30, and square it, and then my second entry was 37 squared, and then my next entry was 32, so we'll square that, and again we know there's going to be 2 of them eventually, so here's our 2 for when we get to the second one. Then our next entry was 39, and then 34, and then the second 32. We're going to divide that by n, which was our 6, and then we're going to subtract our mean squared. So there are pros and cons to these methods, because for this one I'm going to end up working with huge numbers. However, I only have to subtract the mean squared one time instead of having to subtract it every time. So it may be a little less writing, but you have a lot larger numbers to deal with. Whereas the other one, you could probably do most of the computations in your head, you just have more to write out. In either case, you'll notice that when I find that sum, it's 6,994 divided by the 6, and then 34 squared gave us the 1,156. So when I throw that into my calculator, I again get 9.6 repeating. So it doesn't matter if I use this formula or if I use this formula, I'm going to get the same answer either way. So try them both tonight, see which one you like better, and then I don't care which one you use when it comes to your test. Now, every one of these things that we have done thus far, we could do as well on the graphing calculator. So I'll show you how to do that when we get together again. I'll show you how to do every one of those skills on the calculator. Alright, so I understand all of those numbers that I just got, but I don't know what to do with that. What does that represent? We've talked about mean and median and mode, and we've talked about what variance and standard deviation mean, but here's where I would see them used. I'm sure that you've heard the saying of curving a test. When you curve a test, that is not just throw 5 points on the top of everybody's grade because the grade wasn't where I wanted it to be. But that's typically what most people think of as a curve. If the class average was a 75, the mean, and I want that mean to be an 80, then I'm just going to add 5 points to everybody's test. In mathematics, however, when we're talking about a curve, we're talking about something called a standard normal distribution. This is a standard normal distribution. It is a bell curve. It gets that name because it kind of has the shape of a bell here. In a bell curve, what you're going to do is you're going to put your mean in the center. So our mean was 34. And then when we move to the right, we're going to move one standard deviation to the right. So since the standard deviation was 3.1, we'll say 34 plus 3.1. That would give us 37.1. And then if we go to 2 standard deviations, that just means we're going to add another standard deviation. So add another 3.1, and that'll take me to 40.2. Add another 3.1, and that'll take me to 43.3. I could do the same thing on the other side, where I could subtract 1, and that would take me to 30.9. Subtract 2, that would take me to 27.8. Subtract 3 standard deviations, so that again, that means I've subtracted 3.1, 3.1, 3.1. That would take me to 24.7. So the idea is that within one standard deviation, so between 1 and -1 here, within one standard deviation, you should have about 68% of your data. So if we were talking about a test, these obviously aren't test scores, but if we were talking about a test, you would want 68% of your grades to be within one standard deviation of that mean. And then within 2 standard deviations, so 2 going in each direction, you would want about 95% of your data. And then within 3 standard deviations, you would want 99%. You have to have that, 1% outlier for the extreme high or the extreme low that you might encounter. So when we talk about curving a test or curving a grade, in essence, you want the bulk of your scores to be here in the center. So you might think of it as, it would depend on the institution and the professor, but a college professor might think, okay, I want the majority of my scores to be C's. So I would want all these numbers in here between -1 and +1, I would want those to be C's. And then I would want to have the same number of B's over here as I do D's over here. And I would want to have the same number of A's over here as I would have F's over here. So you need to be very careful when you ask your teacher for a curve, because if we were looking at our course on Jupiter grades, if I pull it up, it's going to show, okay, the mean right now is an 85, and you can see we do have something that looks very much like a standard normal distribution. It does look like a bell curve. However, our bell curve is way high. If I were to move this so that it looked like a traditional standard normal distribution, guess what? Everybody's grades are going down, right? Because I need the majority of my grades. If it's going to make a normal bell curve, I need the majority of my grades here. The majority of my grades are over here. So if I were to curve your grades would actually go down instead of up. So again, a traditional curve is not what we tend to think of, where we just add points. When you get to college, if you have a professor that curves your grades, it's going to be most likely something more mathematical like this, where they're going to go through and they're going to say, okay, I need the majority of the grades to be C's here, same number of B's as D's, same number of A's as F's, and they'll recenter the grades in that way. We could get really elaborate with that and go into the topic of a Z-score. When I was in calculus at Armstrong, when I would get a test back on the top of it, it would not have a grade like a 90 on it. It would have a plus 1.7 or a minus 0.5 or whatever it was. He was giving a Z-score where basically you could see where you related to the standard normal distribution of the class. So your goal was definitely to be up in here somewhere, right? So that when he did make the curve, that you would end up in this region where you wanted to be. So, any case. So look at example 3 and example 4 in your textbook. For example 3 on page A24. It says, consider the three sets of data represented by the bar graphs in figure B7. Which set has the smallest standard deviation and which has the largest? Now, you could look at those and get a pretty good idea of what has the smallest standard deviation. Again, we're looking for the smallest dispersion of data away from the mean. That means we want most of the data in the center. We want our tallest bars in the center close to the mean and our smallest bars on the outside, on the outskirts, spread furthest away. So that would be like set A. Whereas if they said what's the largest standard deviation, that means that you want just a little bit of your information in the center and you want most of it spread as far away from that center as you can get. And so that, of course, would be set C. Now, if you wanted to, you could go through and algebraically calculate those as well. That's what they do in example 4. They literally go back and, for instance, looking at set A, you can see that there was 1 1, there were 2 2s, there were 3 3s, there were 5 4s, there were 3 5s, 2 6s, and 1 7. So we could go through then and we could use our variance formula and then take the square root of that to find the standard deviation and repeat that same thing for B and C. And sure enough, what we thought was correct, that A has the smallest standard deviation and C has the largest standard deviation. But we also could look at the graph and make sense of that as well. All right, then the next thing that we want to look at is over on page 827, where we talk about Box-and-Whisker plots. To do that, we're also going to need to talk about quartiles. Where standard deviation is the measure of dispersion for the mean, it shows us how far away from that center average our information is spreading. Quartiles are the measure of dispersion for the median. So quartiles show us if we're going to use a median as our measure of central tendency, as our middle, as our average, then quartiles will show me how far my data is spread away from the median. The first quartile is my lower quartile, and it is the median of the first half of the numbers. My third quartile is my upper quartile, and it's the median of the last half of the numbers. So let's take that same set of 6 numbers we were working with earlier. We had already gone through and put those numbers in order from largest to smallest and gone through and found our median was 33. If you'll notice, that median splits that group of 6 numbers up into 2 halves. So if I look at the first half of those numbers, 30, 32, and 32, that's the first half of my numbers. If I find the median of that first half, the median of that would be 32. That is my lower quartile, or my first quartile. If I look at the second half, my last half of numbers, 34, 37, and 39, the median of those 3 numbers would be 37. That would be my third quartile, or my upper quartile. So occasionally when you get standardized test results back, it might talk to you about percentiles and quartiles, like you were in the 95th percentile, meaning that you scored better than 95% of students who took this type of thing. So quartile is kind of the same idea. It's like we're looking at 30 was the lowest and 39 was the highest. So when we're making a Box-and-Whisker plot, we're going to draw a number line that goes from our lowest value to our highest value. And we're literally making a number line where count by ones, count by twos, but it needs to be a legitimate number line. We're not skipping values. We literally graph it out as a portion of a real number line. Then I'm going to go through and I'm going to fill in my quartiles. So you can see right here, my first quartile was 32, so we'll draw a line there. My third quartile was 37, we'll draw a line there, and my median was 33, we'll draw a line there. And with those three lines, I'll make a box. So the idea is that's my box, and then the lines that go out to the lowest and the highest are my whiskers. But in essence, what we can see here is we can easily see the range of information that it went from 30 to 39. I can see where the center of that was, and I can see where the lower quartile was and where the upper quartile was. So in essence, I'm looking at, if I broke this into quarters, here's the first quarter, or the first 25% of my students, here's the second quarter, or the second 25%, the third quarter, and then the fourth quarter. So that gives us a way of representing the information based on the median. All right, let's look a little more at those quartiles for just a second. What if I had a larger list of information? Let's look at what I do if I have an even number of entries and what I do if I have an odd number of entries. So, for instance, if I have an odd number of entries, I could go through and say, okay, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if I have an odd number of entries, first I've got to put them in order from largest or from smallest to largest. I could go through and, cancel 27 with 66, cancel 28 with 64, cancel 30 with 62. But we literally will have lists sometimes that have a couple of hundred in them. So what's better to do is to go through and say I have a total of 11 entries. Let's divide it by 2. So that means that I'm going to have 5 entries on each side with a remainder of 1 in the middle. So that makes it easier because I know if I count over to the 6th number, that's my median. If there's 5 numbers on each side and there's 1 left in the middle that's going to be my median, that means that if you start at either side and count over to the 6th number, that'll be your median. So if I had something crazy like 201 entries, I would know that if I counted over 100 from either side, that the 101st entry would be my median. So we can count over then and say that our 6th entry is our median. Now, you are going to ignore your median when you're looking for your first and second half. So ignoring that median, that gives me 5 numbers in the first half and 5 numbers in the second half. So to find my first quartile, I'm going to find the median of that first half of numbers, so that'd be 30. And to find my third quartile, I'm going to find the median of those second half of 5 numbers, so that third quartile would be 62. If instead I had an even number of entries, again, I could do the same thing where I could count them all up and say, okay, there's 10 this time, divided by 2 is 5. That means there's going to be 5 entries in my first half and 5 entries in my second half. So looking at the first half of the numbers, my first quartile would be 13, and my third quartile would be 24. And of course the median would be 17.5, but again, I'm going to ignore that. So for our homework tonight on pages A28 and A29, you see your assignment there. Of course, we do not have a quiz Thursday. Yesterday was Thursday, so we are working towards our test next Wednesday on this information. We do not have another quiz next week. We are just working towards the test on Wednesday. So with that in mind, remember, as I mentioned to you yesterday, you're going to need a non-graphing, non-scientific calculator for the first page of your test, something that just adds, subtracts, multiplies, divides, and takes the square root, so that you have something to help you do mean, median, mode, variance, and standard deviation. So again, be sure you have something like that for next Wednesday. Alright, so you have about 15 minutes remaining in the period. So here's what I want you to do. If you had any questions about last night's homework, I want you can work by yourself or you can work in a group with a couple of other people. If you work in a group, you must be diligently working, or you're going to be required to break up and work independently. So be sure you stay on task and you work diligently. But if you had any questions from homework from last night, you can compare with someone around you and get them to help you with it. or you can grab the solutions manual in the front of the room and look at it to help resolve your questions. Then once you've gotten your questions resolved from last night and you feel comfortable, then you're welcome to continue working in your group to begin working on this homework. And this homework is due on Monday. If for any reason you have not yet turned in your notebook, you need to put it on the back table to be graded. Also remember that Monday night at midnight is the end of participation. So if you are going to do any kind of online posting, it must be done by that time. Additionally, next week we will have our Skittles lab on Tuesday, and then we have our test on Wednesday, review homework coming in on Wednesday, both online and in written form as a quiz grade. If you have any questions about anything else or you need my help with anything else, please feel free to shoot me an email.